Welcome back for lesson number 2. Now that we've solved the problem in the previous density problem, the mass that we calculated was 0.88 kilograms. So if you go back carefully through that problem, you should get 0.88 for the answer to the mass for the cannonball. All right, now our second lesson is about pressure. So what is pressure? And pressure is defined by this formula. So pressure is equal to the force per unit area. And of course it has units of newtons per, remember this is physics, square meter. So that's the definition of what pressure is. All right, now if I think about what pressure is, I'm going to try to do some basic experiments here. So let's suppose, for example, I take my 10 Newton finger, and I'm going to use this finger to push with a force of 10 medium-sized apples. So when I push this finger, and I push it onto my forehead like so, and I push with a 10 Newton force, I do feel the pressure a little bit on my forehead. And, you know, I sense it, yeah, but it doesn't really physically hurt me in any type of way, so I'm pretty comfortable with that 10 Newton finger pushing on my skin. Now, the next thing I'm going to try is this. I'm going to take a pencil, and I'll use the eraser part of the pencil. Now I'm going to push on my head like so, and as I press, I'm pressing with the same force, 10 newtons, on my forehead. Now all of a sudden it's starting to get a little bit on the uncomfortable side here, because as I push now, it's kind of actually affecting my forehead, and I'm starting to feel a little bit of pain. All right, now I'll take a moment out, just bear with me. I'm going to go over and sharpen this pencil, and I'm going to get the point very, very sharp, and see what happens when I push this into my forehead. Ouch, that point is sharp, I'll tell you. So as I push that point into my forehead with a 10 Newton force, all of a sudden, it's starting to really hurt now. I think if I actually press with the full 10 Newton force, I think I would start to bleed. So I'm not going to do that. So the force itself, I haven't really changed that. It's been 10 newtons the entire time, but something changed. If I use my finger versus using the end of the eraser versus the sharp pencil, something's changed. It's not the force, because I've been pushing 10 newtons the entire time. What has changed? And the answer is the pressure has changed. So the pressure has to deal with two things. You have to worry about the force, and you have to worry about the area that that force is being applied to. Tragically, I did hear about a friend of mine was telling me about someone that had used an ATV a couple weeks ago on a frozen lake. You know, unfortunately, when they put the ATV on the lake, the amount of force, it was fairly heavy, and it was over a very small area because the tires themselves are not that large. The ATV actually went through the ice, and then the person was actually in the lake in that frozen water, and it had a bad outcome. Now, what would you do? Let's say you're on that frozen lake, and you wanted to actually get off the lake in a safe manner. Well, the trick here is you can't change your force. Your weight is what it is. I mean, you can't go on a diet when you're in the middle of the frozen lake and the ice is starting to crack. So the thing to do is to make the area larger. So what would you do? Maybe you lay down, roll your way back to the land. Anything that you could possibly do to make that area larger, you should actually try to do that. Your feet are relatively small, so anything you can do to improve or make that area larger, that would be helpful and probably do the safest thing. Now, when we measure pressures, pressures are measured in various units. All right, so perhaps one that you're familiar with, pressures, let's say in chemistry, 1 atmosphere was very popular. So if we look there, that 1 atmosphere is very good. Chemistry also uses 760 millimeters of mercury. All right, that would be the atmospheric pressure if you took a column of mercury and put it into a bowl, flipped it upside down. If there's a vacuum above it, the air pressure actually pushes the mercury up in the tube 760 millimeters. We have one hanging on the wall if you want to see it. Some people call it a barometer, you know, so there's something to think about. All right, now we also can call that torr, so 760 torr after Torricelli. He's the guy that drilled a hole through his roof of his house and then tried to see how high a column of water would go through. I'm sure Mrs. Torticelli was very angry at the fact that he put a pipe up through the second floor of the house and filled it up with water. And then one that we typically use in physics, 1.013 times 10 to the fifth newtons per meter squared. That's also equivalent to 1 atmosphere. And this is also, if you would like to shorten that, 1.013 times 10 to the fifth pascals. So this is the metric unit for pressure, which is typically done in pascals.